Welcome to episode 3 of making a particle simulation in Python. This is my newest version of the simulation, and these particles, they won't right now because they seem not to want to, but they will eventually touch and they will bounce off each other. This is an improvement on my last version, which I showed in the last episode, which as you'll see, I added a button to it, which you can click. Turns up the temperature on this display. Doesn't actually turn up the temperature of the system, that's rather more complex, but it turns up the temperature on this display. And these particles, although they bounce off the wall, as you can see there, bounce off the wall, they don't actually bounce off each other, which is obviously a large shortfall in motion mechanics. Pretty big aspect that, but the thing is, it's quite hard. The theory of it isn't hard, but it's quite hard to make an efficient system to detect whether the particles are bouncing into each other, because you have to monitor a lot of different points at the same time. Quite an efficient way to do this is to use hitboxes, and what that is it's basically a series of points which trace out a rough shape around a shape that you're animating, and all of these points are monitored, and if another point from another shape touches or comes close to one of these points, you know not only that the shape has been touched, but where precisely the shape has been touched. And I've decided to go for eight points to make my hitbox around each of my circles. I've got a point for the top middle, bottom middle, the left middle, and the right middle, and also the top left diagonal, top right diagonal, bottom left diagonal, and bottom right diagonal. So yeah, I'm already monitoring quite a few points there. And how have I defined those, you might be thinking? Well, I've defined them in relation to their distance from the middle of the circle. And if you look here, actually, you've seen this. That just sets the particles off on their way initially. And this, I believe, used to be called just collisions, but I've called it wall collisions now because this explicitly deals with the wall collision. So you've seen all this before. This is where it gets a bit more complicated. Ignore this for now, but let's talk about this here. So I've defined, for example, I've defined the bottom middle as the x of it is self star pos 0, so that's the first x coordinate, minus 50. So the x coordinate of that point, the hit point, is 50 lower than the x coordinate of the middle of the circle. Makes sense. And this deals with, ignore all this, but this will deal with the y, and that's unchanged, because the, oh no, sorry, it's the other way around, yeah, sorry. So, the y is 50 lower. The, sorry, this is the left, I'm confusing myself now. This is the leftmost point of the circle. So the x is 50 lower, so it'll be 50 to the left. And the y is unchanged, because if you imagine the circle, I'll run it actually, I'll show you. So if you see the circle here, there's the center, and 50 to the left, so minus 50x will be that left middle point, and that's what I was defining there. So I do this with basically all the points, that's why I've got all these lines here. And if you think about why I've got these brackets here, well, I use a function, a built-in function of Python called math.hypot, and I won't go into the maths of that. You might recognize the term hypotenuse, but I won't really go into that. Basically, all you need to know is it's a function, and what that does is it calculates the distance between 2 points. Now, what you need to do is you need to get the x-axis of the first point and do minus the x-axis of the second point, then the y-axis of the first point, and you need to do minus the y-axis of the second point, and you put that in brackets next to that function, and that will give you the distance. I've done this for all the points, and I've named them all dist 2, 3, 4, 5, so on. And the thing is, if this is basically if dist 0, which is the absolute distance between the center of the circles, are less than 103, because 50 is the radius of the circles, so 100 is if the distance is less than 100, the circle should be touching, and I've added an extra 3 on because sometimes they don't move 1 pixel at a time. So basically, if the circles are touching at all, if dist2 is less than 50, so if the distance between the center of the second circle and the center of if the distance between the center of one circle is less than the distance from that center to point 2 to hit point 2, then this runs. I'll show you what this is. Go back up here. That's x speed change. Then the x speeds of both particles will change because I'll show you. No, that's a fucked up one. If that was hit here, well, it's more accurate if they're moving, but if that was hit on the left, then the y speeds of the particles wouldn't change, the x speeds would. So if something comes up here and it goes boom, the y speed wouldn't noticeably change, just the x speed would change. It'll come up here, it go boom, bounce back. The x speed would change. So that's why I need to have different functions depending on which point is hit. So it's different if point 3 is hit and I run total speed change for that, because we're not just changing the x speeds, all of the speeds would change. Now, of course, this isn't accurate, as you might have caught my gaffe before. If one of the particles is stationary, if you invert the speed in one axis, then it's still 0. So that's something that I need to work on. But basically, depending on which point is hit, which point is the closest to being hit, one of these functions will run, and depending on which one it is, either the x speeds of both particles will change, the y speeds of both particles will change, or all of their speeds will change. Now, this is very complex, and it's hard to apply this to more and more particles, but hopefully I will be able to. So if you know the basics of Python, here you go, here's y speed change and here's total speed change, just basically inverting, so just doing that speed is the inverse of itself, so it just inverts it, makes it negative. So yeah, hopefully I'll be able to carry this on and put some more particles in. I can only do 2 so far, but yeah, hopefully I'll be able to improve that. Okay, thanks for watching. That's it. See ya.